Hello, this is the final video on the topic of turbine. In the previous video, we have looked into the materials that being used for the nozzle guide vanes as well as the turbine disc. So for this particular video, we will look into the materials used for the turbine blades. A brief mention of some of the points to be considered in connection with turbine blade design will give an idea of the importance of the correct choice of blade material. So the blades, while glowing red hot, must be strong enough to carry the centrifugal loads due to rotation at high speeds. A small turbine blade weighing only 2 ounces may exert a load of over 2 tons, okay, at the top speed, and it must withstand the high bending loads applied by the gas to produce the many thousands of turbine horsepower necessary to drive the compressor. So turbine blades must also be resistant to fatigue and thermal shock so that they will not fail under the influence of high frequency fluctuations in the gas conditions, and they must also be resistant to corrosion and oxidation. In spite of all these demands, the blades must be made in a material that can be accurately formed and machined by current manufacturing methods. From the foregoing, it follows that for a particular blade material and an acceptable safe life, there is an associated maximum permissible turbine entry temperature. As I highlighted earlier in the previous video, the higher turbine entry temperature, it will produce a higher thrust. However, there are a lot of limitations and a corresponding maximum engine power. It is not surprising, therefore, that metallurgists and designers are constantly searching for better turbine blade materials and improved methods of blade cooling. Okay, that's why there are still methods being developed to ensure cooling is sufficient and new materials for the turbine blade. Over a period of operational time, the turbine blades slowly grow in length. This phenomenon is shown or is known as creep, and there is a finite useful life limit before failure occurs. The earlier materials used were high temperature steel forging, okay, for earlier design of engine, but these were rapidly replaced by cast nickel based alloys which give better creep and fatigue properties. Close examination of a conventional turbine blades reveals a myriad of crystals, okay, myriad of crystal that lie in the direction or equiax. Improved service life can be obtained aligning these crystals to form columns along the blade length produced by a method known as directional solidification. So a further advance of this technique is to make the blade out of a single crystal. Okay, example is given shown here in figure 12, where various turbine blade crystal structure, okay, as we can see here, directionally solidified, okay, turbine blade, right, and this one is conventional cast turbine blade, the old one, okay, and then single crystal turbine blade, so the new and modern turbine blade. Each method will obviously extend the useful creep life of the blade as shown in figure 5.13. So comparison of turbine blade life properties, okay, so you can see here equi-X blades shown in blue, and directional solidified blades shown in the green, okay, shown in green, and single crystal blade shown in the orange. Okay, as we can see here, the temperature operating can be substantially increased if you use a single crystal blade, right? A non-metal based turbine blade can be manufactured from reinforced ceramic. So there are also cases that ceramic blades are being used. Their initial production application is likely to be for small high-speed turbine which have very high turbine entry temperatures. The last but not least of the topic for turbine is the balancing. We will look at the brief description on how balancing is being done for the turbine. The balancing of a turbine is an extremely important operation in its assembly. So in view of the high rotational speeds and mass of the materials, any unbalance could seriously affect the rotating assembly bearings and engine operation. So balancing is affected on a special balancing machine. So you can Google or look into other references on how balancing being done for the turbine. That would be the end of the video series for turbine. I hope you already enjoy. Do not forget to put comments or questions with regards to the turbine topic. Thank you for your attention, and we shall continue in the next video on the nozzle. Bye bye and Assalamualaikum warahmatullahi ta'ala wabarakatuh.